Okay, so I'm going to be working through number 4 on Thursday's worksheet. I picked number 4 because it basically covers everything. It covers how do you figure out what the limiting reactant is, what's the maximum amount of product you can make, and then also how much of the excess reactant, or in this case reagent, the same thing, how much of the excess is going to be left over. Now, this is something we did on Tuesday, but it's sort of a repeat. So this is not new, it's just more practice. So let's begin. So in order to figure out the limiting reactant, again, if you look right here, we got 15 grams of this stuff, and we got 10 grams of this stuff, and we're trying to figure out which one is the limiting reactant. Now, it doesn't tell you which product to look for, but you can look for either one, because if water is the limiting reactant for aluminum hydroxide, then of course it's going to be the limiting reactant for hydrogen sulfide as well, right? So you can just pick one and just make sure that you're testing both against that one. It's a silly reason, but I am going to pick this one right here because there's less writing than this right here, and sometimes that's your rationale is just that simple. I just don't want to write all that, so I'm going to be picking this one. All right. So I'll start with aluminum sulfide. If we got 15 grams of aluminum sulfide, we have to convert that into moles. So we're going to need the molar mass. And I got my calculator and my periodic table right here. So looks like we got 2 aluminums. Each aluminum is 26.98, so 26.98 times 2. And to that, I'm going to add 3 sulfurs, so 3 times 32.07. And I get 150.17. So 150.17 grams is 1 mole of Al2S3. So it is 15 divided by 150.17, and I get 0.9988. So I'm going to call it So 0.9989. I went a little bit further than probably than necessary, but I just didn't want to round too much with a number. Oh, and sorry, this is 0.0999. So whoops, let's get rid of that. Okay, let's just tidy this up. I'm sorry about that. There we go. That's better. So this is how I rounded, just because I didn't want to shave off too much by rounding too much. Okay, so anyways, back to what we were doing. This is moles of aluminum sulfide. So how much product do we get from that? Well, the molar ratio is 1 to 3. So 1 mole of, I'm not going to write out the whole thing. I'm just going to write the aluminum compound. And this is to 3 moles of H2S. Okay. And now let's just figure this out. So times 3, I get 0.2997 moles of H2S. Okay, now let's just do the same thing with water. So 10 grams of water is how many moles? Well, water is easy because it's 18.02 grams for 1 mole of water, right? Because O is 16 and each H is 1.01, so that's 18.02. So 10 divided by 18.02, and I get 0.555 moles of H2O. And you can tell from the screens that somebody just played their chess move. Yeah, I'm in the middle of a sort of a worldwide chess tournament right now. So yeah, that's the nerd factor. That's what I do. That's how I get down. So anyways, we got our molar ratio here is 6 to 3. Again, we have to be consistent. We got to compare both to H2S. So this is going to be 6 moles of water will produce 3 moles of H2S. So 0.555 divided by 2, really. And that is 0.2775 moles of hydrogen sulfide. And now we just compare these two numbers. And we can see that H2O is a limiting reactant because it produces less, right? Okay, that takes care of this question. So what's the maximum mass of hydrogen sulfide that can be formed? So So now that I read this question, I guess it's good that we tested it against this so that we don't have to redo everything. So maybe that's a tip moving forward, is maybe just take a quick look at the other questions to see if you can save yourself time. It just so happened that I did already calculate this, so this is going to be easy. So we can only produce 0.2775 moles of hydrogen sulfide. So all we got to do is get the mass now. So hydrogen is 1.01. We got 2 of those plus sulfur, which is 32. So 32.07 plus 2.02. That's the 2 hydrogens. 34.09. So 34.09 grams for 1 mole of H2S. How did I know that this went on the bottom? Because I know that this is on the top. That means that this has to be on the bottom in order to cancel out, leaving only grams. Makes sense, right? It should. I have 0.2775. So we multiply these two numbers together at the top, and we get 9.46 grams of hydrogen sulfide. Okay. Cruising. We're cruising through this. Okay, so the last question, part C, is how much excess reagent or how much excess reactants left over after reaction is complete. There are a lot of ways to do this, but the easiest way, I think, is to take a look at the amount, here's my highlighter, the amount of limiting reactant that's used. So we said that water was a limiting reactant, right? We said that right here. So how much water is being used? So I'm going to take this number right here, and I'm going to figure out, if I use that many moles of that, how many moles of the excess stuff am I going to use? And then I just do a subtraction after that, right? So the best way to do this, again, is to take a look at your limiting reactant and figure out how much of the limiting reactant you use, which is all of it, by the way, of course, and then do the molar ratio to figure out how much of the other stuff do you use. So let's just do it. So this is going to be 0.555 moles of water are totally used up. Now the molar ratio between it's a little messy up there, but the molar ratio between water and aluminum is going to be 6 to 1. So 6 moles of water need to react with 1 mole of Al2S3. So 0.555 divided by 6, I get 0.0925 mole. That's a 5 moles of Al2S3. So that's what's being used. How much did we have? Well, again, take a look up here. I'm going to highlight that in purple. Remember, we already know that our 15 grams of aluminum were 0.09989 moles of that stuff. So that's how much we had. This is how much we used. So it's just a simple subtraction. So 0.09989, that's how much we had, minus how much we used, will tell us how much is left over. So 0.09989 minus 0.0925, and we get 0.00739 moles of aluminum sulfide left over. It doesn't ask us for the grams, but just to carry this through, just in case, 0.0739 moles of, how many grams is that? I don't have to recalculate. I already figured out that the molar mass was 150.17. So 150.17 grams for 1 mole of that stuff. So times 150.17. Looks like we have 1.11 grams. The question didn't specifically ask for the mass. It just said how much, but just in case, here's how you would do it both ways. Ta-da!